In this problem, we see that the radius of the circle is 235 meters and the angle theta is 17.5 degrees. As you can see in the free body diagram, we have the force of gravity going down, the tension force in the y and x component, and as you can see, theta is 17.5 degrees. We know that the tension force of the lamp that is being suspended is equal to the centripetal force, and the equation for centripetal force is Fc equals mass times velocity squared all over the radius. In this case, the horizontal component equals the centripetal force. So as you can see on the free body diagram, the force of tension times the sine of the angle theta, which is sine 17.5, equals mv squared over 235, which is the radius. For the vertical component, which is the gravitational force, we know that the force of tension times the cosine of the angle theta, so cosine 17.5 equals mass times gravity, or the force of tension times cosine 17.5 equals 9.8 times m. So right now we have the two equations for the horizontal and vertical components. For the horizontal or centripetal force, we have Ft times sine of 17.5 equals mv squared over 235, and for the vertical component, the equation is Ft times cosine 17.5 equals 9.8 times mass. So what we do now is we divide the centripetal force equation by the gravitational force equation. So as you can see, we have Ft over Ft times sine over cos of 17.5 equals mv squared over 235 times 9.8 m. And after canceling out, we find that Ft over Ft equals 1, sine over cos equals tan, and we can cancel out the two masses in the fraction to give us tangent of 17.5 equals v squared over 235 times 9.8, which is 2,303. The tan of 17.5 is 0.315, so 0.315 equals v squared over 2,303. And to solve algebraically, we know that v squared equals 726.1, or v equals 26.95 meters per second, and that is your final answer.